This week we're going to be talking about trigonometric relationships and trying to find angles in a triangle. We're going to also be able to decide and find the length side of triangles. We're also going to be talking about special triangles also. So one of the things you have to know is trigonometric functions. You have to know sine, cosine, tangent. You also have to know cosecant and all that, but we talked about this last week. Sine of a theta, sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of an angle is opposite over adjacent. So we're going to use these facts to find missing sides. So for example, if I'm given this problem, it says using trigonometric functions to find a missing side. So what we want to do is we want to set up a diagram. And for example, this problem here, we have x, a, and 25. You have to know at least two of the angle or the side measures to find the other, or I guess you don't. We could find both of these side measures if we want to. First thing we want to do is we want to always figure out which angle we're looking at. So in this problem, it gives me the angle of 42 degrees. So that's the one I look at. So I'm going to set up. So I always draw an arrow. That always points to the opposite side. Hypotenuse is always opposite the 90-degree angle. And then the one that's left over is called the adjacent side. So if I'm looking for a side BC here, okay, this side right here, I'm going to use, so I know what this side is. I know I'm looking for this side. So which trig function uses opposite and hypotenuse? Well, sine does. So I'm going to use the sine of the angle, which is 42 degrees, is equal to the opposite side, which is x, over the hypotenuse, which we know is 25. So now the sine of 42, I don't know what that is. I have to get a calculator out to do that, and most of you will do that also. The Desmos calculator has it in there, so you can also go to that. So let's go to the next page. So if I wanted to, oh, I thought I had this. Okay, here it is. So the sine of 42 is equal to x over 25. The sine of 42 is 0.6691306. You don't have to carry out all these, but try to carry at least 4 decimal points, or else your answer is going to really come up wrong. And then I would just cross multiply. Just multiply 0.6913064 times 25. So x is approximately 16.72, or approximately 17 for my answer. Let's try another one. In this problem, it says I'm going to try to find side AC here, okay? So first thing, again, I'm going to do is I'm just going to look at the angle measure. So this is my angle measure. So this is the opposite side. So hypotenuse, this is adjacent. So again, this one is going to be a sine function. So the sine of 50 degrees is equal to question mark, or opposite over hypotenuse. Well, the sine of 50 degrees, I'm going to get my calculator out. Make sure when you have your calculator that you go into mode and you make sure that you are in degree mode, because degree mode and radian mode is totally different. Mine was in radian mode, so I'm out of there. So now I'm going to do the sine of 50 degrees, which turns out to be 0.76660 is equal to opposite side over 6. I could just put an x here, and then I'm just going to multiply by 6 here, and I end up with 4.59 for my answer. Okay, so this week you have to be able to use the 6 trig functions. Really, you only have to use 3 of them, because you can always set them up as sine, cosine, or tangent. You don't need the cosecant, secant, or cotangent when you're trying to find a missing side. To find missing sides, we're also going to be using what is called special triangles to find missing sides. There are 2 special triangles, a 30, 60, 90 degree triangle and a 45, 45, 90 degree triangle. These are pretty important. Make sure you memorize these, because it really is going to help out in the long run when you're doing these types of problems, okay? Now, if I was going to do these, a 45, 45 degree triangle, I'm going to try to explain this to you guys. If you had a square, okay, and all squares have equal sides, right? So let's say I said that this side is 1, this side's 1, this side's 1, and this side's 1. Well, in order to create a special triangle, all we have to do is cut the square in half. Okay, so I'm going to cut the square in half. So now if I cut these angles in half, this would be a 45, 45, 90-degree triangle. So I'm going to write this, I'm going to write it over here a little bit so we can see it without it being stuck in there in the square. So that's 45, 45, 90. We know that if this side is 1, this side's 1. Well, I can figure out this side by just using the quadratic, or not quadratic formula, Pythagorean theorem, a squared plus b squared equals c squared. So 1 squared plus 1 squared is equal to c squared. So that's 2 is equal to c squared, c is equal to square root of 2. All right, so this always holds true. So if I gave you a triangle like this, if I said, okay, this side is 5, what are the other sides? Well, I know this side has to be 5 because it's a square. They have to be the same. And then it's just the side times the square root of 2 would give us the hypotenuse, 5 square root of 2. Now, if you don't agree with me, work it out. 5 squared plus 5 squared is equal to c squared. So that's 25 plus 25. That's 50. The square root of 50 I can break down to the square root of 25 times the square root of 2. So that's 5 square root of 2. Well, that's a whole heck of a lot of work just to get that. But all you have to do is remember, if you're given the side, it's just the side times the square root of 2 gives you the hypotenuse. Okay, so that's a 45, 45-degree triangle. Now, if you deal with a 30, 60, 90-degree triangle, now a 30, 60, 90-degree triangle deals with an equilateral triangle. If you remember back to geometry, an equilateral triangle, all angles are 60, all sides are the same. Okay, so let's just say that this side is 2, this side's 2, and this side is 2. Now, if I break this in half, if I just draw a line straight down here, well, if I broke 60 degrees in half, that gives me 30, 60, 90. That's a special triangle. So I'm going to draw it over here. Okay, 30, 60, 90. Now, we said that this side was 2. Well, what would this side be now? Right here, it's just half of 2, right? So that side would be 1. Now, if I use Pythagorean theorem, a squared plus b squared equals c squared, you'll find that this side becomes the square root of 3. So if you know the hypotenuse, half of the short side would be 1, and the long side would be the square root of 3. Now, let's say I gave you this. Let's say I gave you a 30, 60, 90-degree triangle, and I said this side was 5. Find the other sides. Well, if the short side's 5, hypotenuse is double it. That's going to be 10. The longer leg is going to be the short side times the square root of 3. Boom. So once you know that, it's really easy to work with special triangles. Now, when we're dealing with trigonometry, these are always going to be really important, because if they ask you, and what's the importance of this? Because tonight what I'm going to do is I'm going to say, I want you to find the exact value of, let's say I ask you to find the exact value of the sine of 120 degrees without using a calculator. Well, I'll be able to tell if you use a calculator, right? Because, you know, kids that do this, they'll go to their calculator, they'll hit sine of 120, and they'll get 0.8660. Okay, right away I know you used a calculator. Why? Because you came up with a decimal for an answer. I don't want a decimal for an answer. I want the exact value. Okay, so how do I do this? Well, I have to go back to last week. I'm going to draw my angle measure in. Okay, here's my initial side. So 120 is going to be here. So then I draw my reference angle in. And my reference angle, if this is 120, my reference angle is 60 degrees. Huh, awesome. Because now, if you remember anything here, I want to know what the sine is. And we always, when we do this type of problem, we always use this side, the radius or the terminal side, as 1. Okay, so I just put that as 1. Well, what is this? This is 1/2. What is this? This is 1/2 times the square root of 3, or the square root of 3 over 2. Well, guess what? This is my reference angle. It is the exact same thing as 120. So the sine of 60 is the exact same thing as 120. Okay. So now, what is sine of this angle? It's opposite over hypotenuse. So the square root of 3 over 2 over 1, which is, this is a complex fraction, so it's just square root of 3 over 2. So my answer is the square root of 3 over 2. Now, if you, let's see here, I messed something up here on my calculator here. Sorry about that. If you go to your calculator and you plug this in, square root of 3 over 2, guess what you get? 0.8660. The answer should be the same, but I don't want it 0.8660. This is the answer I'm looking for. So that's how you find the exact value of a trig function using special triangles. It's so cool. I just love this stuff. Now, the only other thing you have to know in order to not have to use a calculator is you have to know sine and cosine graphs. Okay, so I'm going to talk about those. The sine graph, and we're going to talk about sine graphs and all that. I think next week we're going to be talking about graphing, but you really want to know what these graphs look like. The sine graph, I'm going to call this 1 up here, pi over 2. So sine graph is 0 here. Pi over 2, it's at 1. At pi, it's at 0. At 3 pi over 2, it's negative 1. And then 2 pi. So my sine graph looks like this. And then it would just keep going. You know, it's a sine wave. So if I asked you for values on, you know, exact values. So if I said, what is the sine of pi over 2? You know, you should be able to look at this graph and say, oh, it's 1. If I asked you for the sine of 0 degrees, you should say, oh, the sine of 0 is 0. If I said, what is the sine of pi? You would say 0. Now, why is this graph really interesting? Because it's going to tell you where sine is positive and negative. Anytime it's above the x-axis, it's positive. Anytime it's below the x-axis, it's negative. So I know that in quadrant 1 and 2, sine is positive. In quadrant 3 and 4, because remember, a circle, quadrant 1 is between 0 and 90. Here I can see my graph is above the x-axis. Between 90 and 180, it's quadrant 2. Still above the x-axis, but in quadrant 3, it's below the x-axis. So if I asked you to find the sine of 270 degrees, you know, the first thing you would do is, I wouldn't do a whole lot of work. I just look at this and say, oh, 270 degrees is the same thing as 3 pi over 2. It's negative 1. But you always have to understand that it's going to be negative because it's in the lower quadrant. So sine graph, memorize that. Cosine graph, same thing. Cosine graph, let's say I started at 1 again. I'm going to use 1 up here. Sine graph starts here, then it goes down. Then this would be negative 1 here. Goes down, comes back up here. So this now is my cosine graph. Now, it's exactly the same thing as the sine graph, but it's just shifted over, okay? If you think you just shift this thing over, it would be the exact same thing, okay? So now I know cosine. So if I asked you for the cosine of pi over 2, you should say it is 0. If I asked you for the cosine of pi, you should say negative 1, okay? Those are two really important graphs. If you understand the special triangles and the cosine graphs, there's really nothing I can give you. You don't even have to know the unit circle after this, and we'll talk about that in just a bit. But here's a problem. Well, this goes back to special triangles. Here's a problem. It says or it says find the value of x. You don't have to use a special triangle if you want to, but why would you use trigonometry? I know the hypotenuse is 74, so the short leg is always half of that. So half of 74 is going to be 37. So I know this side is 37. If they ask me for the long leg, I'd say it's 37 square root of 3, because it's always the short leg times square root of 3. So knowing special triangles, amazing. So now if I have a 45-degree triangle and they give me the hypotenuse, remember, we went from the side to here. So to go backwards, we just divide by square root of 2. Because we multiply by square root of 2, we divide by square root of 2. So if I wanted to know this side, I need to turn on my marker here. this would be 20 over the square root of 2. Now, usually we don't leave the square root of 2 in our answer, a radical in the denominator, so I'm just going to multiply top and bottom by square root of 2. So that gives me 20 square root of 2 over square root of 2 times square root of 2 is 2. So that crosses out. That gives me 10 square root of 2. Boom. So this side is 10 square root of 2. This side's 10 square root of 2. Those are exact values. I love special triangles. They're so cool. Here it says not drawn to scale, but they want to know what the two sides are. So this is a 30-60-degree triangle. I know what the short side is. So what is the hypotenuse? Well, the hypotenuse is always double that, so that's 34. The short side, or the long leg of a 30, 60, 90-degree triangle is a short leg times square root of 3. Boom, done. So y is 34, where's y is 34, and x is 17 to square root of 3. Yes, boom. I love special triangles. They really help out immensely. In this problem, remember, I'm given the hypotenuse. To find the missing side, I just divide by the square root of 2, because if I'm given this side, if I'm given this side is 10, this side would be 10 square root of 2, because we just multiply by square root of 2. But if I'm going backwards, I have to divide. So this is going to be 16 divided by square root of 2. Can't leave a square root in the denominator, so we multiply by square root of 2 over square root of 2. So that gives me 16 square root of 2 over square root of 2 times square root of 2, which is 2. So I simplify 8 square root of 2. That would give me my missing side. Again, special triangles are awesome. Now, the last thing that we're going to talk about is the unit circle. Now, you do not need to learn the unit circle if you know special triangles and the sine and cosine function. But the unit circle is kind of cool. I mean, if you memorize the unit circle, and I remember when I was in school, they told us to memorize this thing, and it's like, are you kidding? Am I going to memorize the unit circle? However, you know, I can create the unit circle just knowing the special triangles and the sine thing, and some kids are like, well, how can you create the unit circle? Well, guess what? If you understand the unit circle, okay, I'm sorry, if you understand special triangles and those the trig functions that the graphs I gave you, you can come up with every single angle measure. So for example, if I wanted to know, let's say that this is 1, this would be 1/2, this would be the square root of 3 over 2, okay, right? Because it's 1/2 times the square root of 3. So now, if I wanted to know what the sine of 30 degrees is, the sine of 30 degrees is opposite over hypotenuse. Well, that's 1/2 over 1, which is 1/2. Well, here it tells us that the sine is the y value. So let's go to sine of 30 degrees. It's 1/2. If I wanted to know what the sine of 60 degrees is, it's going to be the square root of 3. It's going to be the square root of 3 over 2. So if I went up to sine of 60 degrees, square root of 3 over 2. So this, if you memorize this, you don't, and some kids are just going to use it in front of them when they're doing their homework assignment, which is perfectly fine, but you should be able to use special triangles to be able to figure out all these values also. And some kids will say, well, Mr. Shangle, how am I going to get 135? Well, isn't 135 the same thing as 45 degrees when you think about it? Because the reference angle, if you drew a line down here, the reference angle would be 45. So the sine of 135 and the sine of 45 are exactly the same thing. So if I knew what the special triangles, if this is 1, this would be the square root of 2 square root of 2. So I know that the sine of 135 is the square root of 2 over 2. It's one of those things that, you know, you have to, if you understand what's going on there, you should be able to figure out all those values. Oh, darn it, I messed this up. There should have been a 2 here. Sorry about that. Now, if it was a 1, it would be 1 over square root of 2. Okay, so that's the unit circle. So everything that we're doing this week deals with that. So if I wanted to find the exact value of cosine of 225, I would find 225. Cosine is the blue one, so that's negative square root of 2 over 2. If I wanted to know what the sine of 315 is, well, Sine of 315 is down here. Sine is the red one, so it's negative square root of 2 over 2. So using the unit circle to find missing or the exact values is another way of doing it. So you've got special triangles, you've got unit circle, both of them work. I don't like it when kids use the unit circle all the time, because if you cannot create that in your head, then you get to like an ACT test or something like that, they're not going to give you the unit circle. So you have to be able to figure out these values without it, and that's where the special triangles come in. Okay? All right. Hopefully we'll see you guys on Monday. You guys have a great week. Bye.